So let's talk about some characteristics of z-scores. First of all, z-scores can be calculated for any distribution of scores. It doesn't have to be a normal distribution. We can have something really unusual, but we can still calculate z-scores. And the shape of the z-score distribution will be the shape of the raw scores. So now it works out especially well for finding areas under the normal curve if it is approximately normally distributed, but the z-score is just a formula based on it's a transformation based on the formula where you find the mean and the standard deviation, and it doesn't have to be a normal distribution. Now, the mean of the z-scores for a population is always going to be 0. So a positive z-score means that it's going to be above the mean, and a negative z-score means it's going to be below a mean. And the standard deviation of the z-scores for a population is always 1, and this will be useful when we want to make sure that there's the same variability when we're comparing different variables. Now let's go back to our IQ example here and start looking at how we can start doing some calculations with the IQ, with the normal distribution. So we might want to ask, what percentage of people have an IQ below 116? Well, we know 50% of the curve is on this side, and there's 34.13% here. So it turns out that 84.13% of the people have an IQ of about 116 or below. And it's kind of interesting because this is the area of people people that tend to go to grad school. And so if you are watching this for OPSI 590, there's a good chance that you are in this 84th percentile of people, which means you've got a big responsibility. People that tend to study stats are people that have the cognitive abilities that enable them to be leaders, and so I'd like this to be a reminder to you that, whoa, you are among that 84th and above percentile of people who can study these things, and that you have a responsibility to use your gifts and abilities for good. Now, as a Christian, that means for me that I want to use my gifts and abilities for the glory of God, to do things that please God and to help other people know who He is. Now, what do we do for z-scores other than exactly plus 1, 2, or 3? For example, what percentage of children have an IQ under 142? We go to about 142 here, and there's no line that says exactly what percentage of people are in that category, so we can't just add these numbers together. The solution is to convert the raw score, the 142, into a z-score and use the norm S dist formula in Excel to get the area under the curve to the left of z. What does this mean? Let's look at this norm S dist function. The normal, it stands for normal standardized distribution, and if we've got a z-score, like 142, or the z-score could actually be on this side, just any z, if we type in equals norm S dist, and then whatever the z value is, like 2.5, something like that, that gives us the fractions of scores below z. It also gives us the probability of getting a score lower than z, is another way of looking at it. So if this z gave us was 85 or 90%, that would mean we'd have a 90% of the z-scores are below that z-score. And so the norm S distribution will tell us what that percentage is. So let's go to our example of what percentage of children have an IQ under 142. What we need to do is we need to convert the data into z-scores and use the norm S dist, don't forget to put the S in there, formula in Excel to get the area under the curve next to z. So our formula for z is the raw score minus the mean, that quantity, divided by the standard deviation. So in this case, the raw score of the child was 142 minus the population mean. The average person's IQ is 100, divided by the standard deviation of IQs, which is defined to be 16. We pop that into the calculator or into Excel, and we get 2.63. And then in Excel, if we were to do norm S dist, open parentheses, 2.63, close parentheses, we would get a score of 99.57%, or 0.9957 if we left it in decimals.